Alright, how's everybody doing? I'd like to introduce you to the Baker Nicholas Show, Week 3. Kevin.
And I'm Andrew, and today we're going to be talking about, the past couple of weeks we've been talking about how our experiences have been going at Blacksburg Middle School. Just in general, really vague, just stuff we've been learning and just our experiences with kids. But today is going to be a little different in the fact that Kevin and I are going to talk about and just really give a step-by-step process of how we interact with a student while solving a problem. We're going to talk about what the student did and whether he or she was correct in what they did, but then we're also going to talk about our instruction that we gave the student and just talk about how that just the process of how helping a student solve a problem is key in just the student's growth.
Yeah, so just really focusing on the whole tutor-2D relationship, and then on top of that, we're going to I guess have a little wrap up about talking about our philosophy of teaching mathematics and why mathematics is taught in high school to begin with. What's important about mathematics? Why do these students need to learn mathematics in a high school setting? How is that going to help them with their life? So I guess to jump things off, I'm going to start off with my one-on-one experience with my student. And so for the past 2 weeks, we've been really focused on the whole solving for variables and the different methods that go around that. So the student that I worked with, we were working on.
I'll get out of the way real quick so Kevin has full.
So we were working on another just another level of equations. I guess this is involving radicals and square roots. So this is the equation that we have. We have the square root of 2x minus 1 equals 2 plus the square root of x. So when we're solving for x, the student he knew initially you need to remove the variable from underneath the radical to solve for it. So the first thing he wanted to do was he wanted to square both sides. So starting with the left hand side, if he had the square root of 2x minus 1 squared, the student knew that the exponent on the outside and the radical would cancel each other out. So he's just being left with 2x minus 1, which is correct. And then, so he had to square the right-hand side, because when you square both sides, you have to keep the equation equivalent balanced. So you square the left-hand side, you have to square the right-hand side. So 2 plus the square root of x squared. Now the student had this as just 4 plus x, and this is where I stopped him, because squaring this whole term doesn't give you this as an answer. What he did is he squared each term individually. So I told him, as an example, I said when you square x, you have x times x. So when you're squaring a term, you're multiplying it by itself. So that's what I showed him that he needed to do on this side, is this is actually 2 plus square root of x times 2 plus square root of x. So when you have to multiply this whole term by itself. So when you multiply this, you do the FOR method. And he understood what I was talking about. He just needed to see that this example right here really helped him, that when you square a term, you're multiplying it by itself. So then he got the correct answer of 4 plus 4 square root of x plus x. So now this is our left hand side and this is our right hand side. So we have 2x minus 1 equals 4 plus 4 square root of x plus x. So now, after he had this filled out, he wanted to bring everything to one side and see if he could. So he wanted to bring everything to one side. So he got x minus 4 square root of x. What is this? Minus 5 equals 0. So now, the bad thing about this is this term right here, we still have x underneath the radical. So he knew, the same thing we did with the first equation, he wanted to square it so that you could get rid of the x. But he didn't want to square this whole thing right here, because he thought that would be too much. So he just wanted to bring this back to the other side. So we have x minus 5 equals 4 square root of x. So now squaring both sides again using the same method as our first step, he wanted to square this left hand side, x minus 5 squared. but his answer that he got was x squared plus 25. And again, like I showed him before with the x term, x squared equals x times x, I just reminded him that this term right here is you're squaring this whole quantity. So when you square this whole quantity, you have to do x minus 5 times x minus 5. So you don't just do x squared to get x and then negative 5 squared to get 25. You have to do the entire quantity times itself. So then he got x squared minus 10x plus 25. And then for the right hand side here, he did 4 square root of x squared, and he just got 4x. Now the problem with this is, like, when you have this one term here, again you're going to be multiplying it by itself. So you have 4 square root of x times 4 square root of x. So now when you multiply, you have this 4 times a 4, then you have this square root of x times the square root of x. So what you're really going to get is you're going to do 16 times x. So I was just really trying to get him to focus on how when you square something, you're squaring this whole term inside the parentheses as opposed to squaring the parts by themselves. So now he's got this left hand side here equal to this right hand side. So after figuring out both sides, having them squared out, he's got his x terms. He's got an x squared term and an x term, and then an x term over here, and none of them are underneath the radical sign. So now bringing this 16 to the other side, 16x, excuse me. He's got x squared minus 26x plus 25 equals 0. And then from this point on, he just saw this as a simple factor, x minus 25, x minus 1. So then his two answers were x equals 25 and x equals positive 1. And I guess the main thing, like I said, like the main, I guess, idea of this whole problem that I got him to focus on was that squaring this term, or squaring any term, is you're squaring everything that's within the parentheses. You're not just squaring each term individually. So that was the main thing that we focused on. And after talking about that, like, I mean, he was comfortable with the math, and when I showed him like the two terms like multiplied by each other, he was able to multiply them out easily, and then he was able to factor this one out with ease too. It's just a matter of getting him to understand that whole squaring, squaring an x minus 5 is squaring x minus 5 times itself. Like, it's not just x squared minus 25. So that was the main thing that we focused on in our problem. And I don't know, he seemed alright. After, I mean, obviously I had to help him out a little bit, but he seemed alright. And that was my problem. And now Andrew's gonna come back and talk about his student and his one-on-one test.
Hey everybody, I just wanted to give Kevin some time to have the floor and just really tell you about his process about solving the problem with his student. So my problem with my student was an Algebra 1 problem, and it was just solving for variables. But the problem we had 3m minus 9n equals 24, and we had to solve for n, right? So his first step, I was working with this freshman guy. He was a pretty nice kid, he needed help on most of his problems, but it was totally alright. But so my first question I asked him, was we have to get the variable m by itself, and so what is our first step? And the student originally said, hey, let's divide both sides by 3. And I was like, alright, well, you can do that, but also the whole first purpose of solving for a variable is to get the variable by itself on one side. So the first step is, if it's ever added, if anything is added or subtracted, you always do the opposite. So I reminded him about that, and he was like, oh yeah. So I was like, alright, since we have a minus 9n here, what do we have to do to get rid of it? And he was like, alright, well, we have to add 9n to both sides. And so we get 3m equals 24 plus 9n. Alright, so of course my next question is always like, hey, what's the next step? What's the next step? Remember, I constantly reminded him we have to get n by itself. We have to. And so he was like, okay. I was like, well, now you can do something that you originally said. And he was like, oh, divide by 3. And I was like, and exactly right. So he divided each term by 3. And when he did that, he divided everything by 3, and so he got m equals, he got the first, he was like, 8 plus, he didn't really know what the next step was. And so I just had to remind him that, 9n divided by 3n, you just have to focus on the coefficients, so 9 over 3. So I just reminded him, hey, what's 9 divided by 3? What's 9 divided by 3? He was like, oh, 3. And so he wrote that down, and then we can't just get rid of the n. So I reminded him, he didn't remember, he was like, oh, m equals 8 plus 3. But I reminded him that we still had an n here, so we had to have an n here. And so I just wanted to ask him, did we get what we had to do? Did we finish the problem? And he said yes, because we have n by itself. We solved for n, because we have m equals something. But now we had to plug in a value. We had to, find, and then our next step was find m when n equals -1. And so that was the next step. And so he immediately, his first step was, m equals 8 times 3 minus 1, which equals 10, which is incorrect, but I didn't just throw it back in his face. But I just reminded him, hey, it's 3 times n here, so for the problem I showed him that, it's 8 plus 3 times n. So I was like, plug in -1 again and see what we get. So he said m equals 8 plus -3 times m equals 8 plus 3 times -1. And so when he got that, he was able to do 3 times -1. So he got m equals 8 plus a -3. And right there, he actually got stuck. He said it was 5, he said it was 11, he said it was, he even said it was 24, because, he just got mistaken that the plus sign was a multiplication sign. So, going back to start at the top, starting this back up here. So I said we have m equals 8 plus a -3. So I asked him, what is another way we can write 8 plus a -3? And he was struggling. But then I reminded him that adding a negative is just the same thing as subtracting the whole, subtracting the positive. So I showed him that we could rewrite it as 8 equals 8, or m equals 8 minus 3, which he easily said is equal to 5. So the student just, probably, my student needed a lot of prodding, which is okay, but the cool thing was that he knew all the steps that he was doing. He really did. He just rushed a little bit. In his division, he didn't divide both terms by the same value. He only divided one term. But most of my responses were very positive, but also just really challenging the student. What's the next step? You've done that. What's the next step? You've done this. Okay, what's the next step? And so I guess the students, that I've seen from tutoring just need a little bit more work and just making sure that whatever they do the one side, they have to do the other side. So I mean, that was kind of how my conversation went. And so the student did pretty well in just Algebra 1 stuff, and we had a whole bunch of problems like that. But that's just kind of how the conversation went for solving this specific problem. Yeah, so that's how our conversations went individually.
Yeah.
But now I think Kevin and I are going to talk a little bit about, what is the purpose of teaching high school mathematics to students? What is our purpose? We've been challenged by multiple teachers already of just what is your purpose for why kids should learn high school math. And I know Kevin's going to share some of his thoughts on that. To start out, to put him on the spot first.
I guess I'll start it off. It's actually kind of funny. Like, I've just been thinking about this ever since Dave asked us in class, like, what goes into like high school mathematics, like why is it important? And this is like kind of like downplays like what we're trying to do here. But when we were in the classroom on Wednesday, we actually left the academic lab and went to one of the actual math classrooms. It was a math analysis class, and they were doing like synthetic division, like solving for x, like with multiple roots. But they were doing like quadratic equations, I guess, like with like x cubed and x to the fourth and whatnot. And they were just like solving that for roots and everything like that. And the teacher looked at us, me and Andrew, and we're seniors and at Tech, math education majors, and they were just like, oh, like how often did you use this in your life? And we were just like, well, we don't. And then the classroom, they just all started laughing. And then the one kid in the back, it was actually a kid that I helped, he raised his hand. He was like, well, if they're not using it in college, why are we doing it now? And to a certain extent, like, there's never a real life situation where you have to know how to solve for roots. But it's all about, to me anyways, like doing mathematics, it's all about like problem solving and like reasoning and proof. Like, these are like all things that NCTM, it's a National Council of Teachers of Mathematics, they've laid out as like process standards for doing mathematics. And so I guess like teaching mathematics in high school and like learning math, it's not about like, okay, do you know that the square root of x, or like solving the problems that we're solving. It's all about like building your mind and like having processes to solve any problem in life. Like, it's not about just math problems and finishing worksheets and doing homework. It's about just having a strong like mental path, like mental schemes to like solve questions, any question that is given to you. Like, if okay, this is all the information that's given to me, what can I do with this information to get an answer, to get a solution? To be able to go through that process, it's a very mathematical way of thinking, but you don't always necessarily have to be doing math. So I guess that kind of goes with the whole philosophy behind mathematics. It's like, it's not always about the math, but it's just about like how you think, like having a strong mind, and that's what I get out of it.
Yeah, a lot of my thoughts and feelings of why I should teach high school mathematics, or why students need to know high school mathematics, also are heavily influenced by the NCTM standards. And like Kevin said, it's the National Council of Teachers in Mathematics or something. And the process standards they set are just a lot about just developing the student's mind and everything. And I 100% agree with that. Sorry about that. We have our dog that's being a little loud. But my views are just a lot of based in just teaching kids how to think. And with just 4-function math, addition, subtraction, multiplication, division, that the kids, our minds are not challenged enough. And so when they face problems in their professional lives, with bills, maybe just even with handling a tough situation of like where they have to do a lot of analysis of just what's the best option.
Right.
If they don't know high school mathematics or they don't have practice with higher level thinking, they're going to really, really, really struggle to be successful or just to be able to function in society without having practiced that in high school.
I like what Andrew said about the higher level thinking, and like you always hear from kids like, or from adults even, that like, oh, I hate mathematics, oh, like I'm not good at mathematics, I can't do it. And it's just like, that's the thing that kind of like gets to me, and it's like, yes, you can do it, and like all you need is that confidence in you, and that's what we as teachers are there to facilitate and there to like help build upon. And like there's this one girl that I work with. She's in the third period class, and every week like she pulls out her worksheet and she's just like, "Oh, I don't know what to do, so I didn't do anything." And I'm like, "Yeah, you do know what to do." So it's just a matter of like getting them through like the like she needs